Education for a discussion of analytical geometry in high school-based vectors. Unsurprisingly affirmed that education in basic education in Brazil faces serious problems. When trying to identify some of the factors that contribute to this situation, it's common to find a lack of physical and technological structure of schools and the teachers poorly qualified and poorly paid, unmotivated by indiscipline and disbelief reigned among students, especially those in public schools. Another factor that seems to have the potential to maximize the problems encountered with the teaching of mathematics in basic education is strengthening the belief in the almost impossibility of learning. The content of this course is on the structuring of the high school curriculum, which can also respond by disinterest on the part of students. The high school curriculum is composed of a large program, fragmented, which makes it impossible to work the teacher so investigative content. Otherwise, you cannot complete the plan for that series. In principle, such a proposal seems legitimate, even if one takes into account that, when starting school, the student is too young to be able to objectively decide on the career that will follow. However, the results observed in the early years of the top courses in the areas of science reveal that the result achieved with this broad curriculum is far from achieving its goals. The vast majority of public school students are leaving school without this level of minimal knowledge of mathematics needed to continue their studies in this area. In the specific case of analytic geometry, the focus of this article, the possible applications arising from this study may, at first sight, justify the need to stay on the list of contents, since the teaching of geometry is of great interest nowadays. Although it is unquestionable, the importance and the use of geometry in the contemporary world, we must emphasize that these applications come from the study of geometry on the upper level of analytic geometry and not listed as content in high school. Given these arguments, we put the research question that guided the entire literature search done for this article. What kind of analytical geometry has figured in high school curriculum? Seeking to answer, we propose a new way of teaching of analytic geometry in high school with the goal of improving student learning and consequently that in higher difficulties encountered today are minimized due to better organization of the contents worked. We think that in this being done, we are contributing to a reflection in teaching analytic geometry, seeking to improve the quality of teaching and learning this content consistent with its usefulness in the contemporary world. The analytic geometry in high school based on vectors in these discussions led to the conclusion that one should teach analytic geometry with vectors instead of analytic geometry renaissance. According to Module 3, analytic geometry makes use of two orthogonal axes to connect the concrete geometry to two somewhat abstract branches of mathematics, arithmetic, and algebra. We will discuss in this paper the theory proposed by Rosa for teaching of analytic geometry in high school from the vectors. To start the study of content, which in our view should be worked in the first year of high school, before the contents of functions, we present the Cartesian plane, which name is associated with Descartes for having been responsible for the sign convention for coordinates of the points below the negative x-axis or left y-axis. From the use of the system orthogonal axes, each point to associate a pair of real numbers called coordinates of the coordinate system fixed. Thus, we may pay attention to the fact that the point, which is the object of study of geometry, is associated with a pair of numbers which are objects of arithmetic and algebraic manipulation. A simple arithmetic operation performed to the point represented by the ordered pair x and y will change this point of position in space. For example, if we add a unit to the ordinate of the point 1 and 2, have vertical movement of a unit of measure for the point, which will now represented by a pair, 1 and 3. Geometrically, we have as it shows in the chart below, in the graph below. At this point, we must pay attention to the fact that the line segments oriented in the plane are not drawn vectors, but it is a representation of the action of the vector v. Each vector has infinite oriented segments that can represent it. For this study, it is necessary to use vectors that represent the various forces, and analogy of some elementary operations with vectors is vital for the learner to determine the resulting force on the body. It seemed to be a great difficulty for the students to solve the problems of dynamics because of the lack of more knowledge about vectors. It seems appropriate that mathematics can work the relevant content broadly that will be used in physics, helping to indisciplinarity as desired. Before starting the elementary operations with vectors, it is essential that the student understands the concept of vector. A previous example can be with the mosquito vector of dengue, that can help the understanding, however, and the formalization for vectors is necessary. It is extremely important that students know that a vector is only defined when the following quantities are defined: direction, meaning, and model. Finally, the model provides information about the size of the vector in question. As already discussed, there are infinite vectors with these characteristics, and use one of them as a representative. This concept must be working very well so that the student can understand that such vectors can be positioned elsewhere in the plan without losing their integrity and, thus, allow proper repositioning of the elementary operations, which we will discuss as following. Elementary operations with vectors. The first operation in the sum of vectors, initially, the procedure for such operation is through the graphical method, with the main objective to verify that the concept previously mentioned about the change vector in the plane was assimilated. We started then a simple problem, suggesting a shift in two successive steps, from a point P equal -1 and -2, we will first displacement vector acquired v1 equal 3 and 1, and soon after the second offset corresponding to the vector v2 equal 2 and 4. Note that the vectors are understood as agents that displace the point. The figure below shows the results obtained and displacements corresponding to the arrival point A equal 4 and 3, as it shows in the figure below. From the realization of the geometric model, the students will understand how to get the coordinates of point A algebraically by doing the following: v1 plus v2 equal 3 and 1, plus 2 and 4, plus 3 equal 3 plus 2, and 1 plus 4 equal 5, and 5 equal r. we define the vector sum v equal v1 and v2 with w equal w1 and w2 by v plus w equal v1 plus w1 and v2 plus w2. Finally, just use the vector r obtained to move the point P to point A. P plus r equal -1 and -2 plus 5 and 5 equal -1 plus 5 and -2 plus 5 equal 4 and 3 equal A. The addition operation, we can study the subtraction of vectors. For this, we define the vector opposite. Such a vector can be understood as the vector that exactly undoes the displacement caused by another. Thus, given a vector v equal a and b, its opposite vector is commonly denoted by -v plus -a and -b, thus subtracting a vector sum in the opposite of this vector. Note that the direction and length are the same between the vector v and its opposite -v, but occurs in reverse order. Thus, we have v plus -v equal 0 plus 0 and 0. Another basic operation is the multiplication by a scalar, a vector, or by a real number. We can think of defining twice the vector v equal a and b, which would cause the effect of the displacement v performed twice repeatedly. It would be natural to denote 2v or 2v equal v plus v equal 2a and 2b, as it is shown in the figure below. In many situations, especially in problems of physics at the first year of high school, the vectors are not expressed by their coordinates, but by their length, also commonly called intensity, clear reference to the forces used in dynamics. Thus, the student should be able to use the information available to solve a problem, and this time, we believe we will study another important aspect, the orthogonal decomposition. Now, at this moment, the student himself is able to establish a way for determining the modulus of the vector. Suffice it to check, and for this nothing better than the graphical method, the vector 3 and 4 is the hypotenuse of the triangle whose other two sides are 3 and 0 and 0, 4. Thus, the length or norm, a concept that can be introduced at this point to describe the size of the vector, will be as it is shown in the equation below. In the second manipulation performed previously, it can be